All right, so this week we're going to take a look at two sections. The first section is 9.4, it's on conics, and the second section is 10.1, and that's solving systems using elimination and substitution. So two different topics, but with the amount of time we have to do conics, we have 1 day left over, so I'm trying to do an easy topic that can be done in 1 day for that last lesson. That's also on the final. So conic sections are basically the different shapes that you can get when you slice a cone. Okay, so think of them as a cross section. So we're going to study 3 out of 4 of them. The one that we're not going to do is the parabola. We'll do the circle, the ellipse, and the hyperbola. So the way that you can get a circle is if you take a cone and you slice it parallel to the base, and then look at the shape after you slice it. An ellipse is when you slice it on an angle to the base, but you come out the sides of the cone. If you start to slice it at a really steep angle and you come out the bottom of the cone, then the shape that you would get after you cut that piece off, the edge would look like a parabola. And the hyperbola, we're going to do that one tomorrow. That's a little bit different. It's when you put 2 cones back to back and then you slice perpendicular to the base. And you actually get 2 parts. Okay, a hyperbola is the only conic section that there's 2 pieces to it. All the other conic sections are in 1 piece. Circle and ellipse are the only 2 conic sections that connect back to themselves and form a closed shape. The other 2 shapes are open, parabolas and hyperbolas. So any questions on the 4 different shapes you can get, 4 conics? So let's take a look at the parabolas. I'm sorry, ellipses. So first of all, every conic that we study, it's a 2-dimensional shape. Okay, they're not 3D. Circles, ellipses, hyperbolas, and parabolas are all flat. And the definition of every point starts out as a collection of the points in the plane that meet some kind of criteria. So for a circle, that would be the easiest one, I think, to define. It's a collection of points in the plane that are all equidistant from a point we call the center. That's how you describe a circle. It's a collection of points equidistant from a single point called the center. An ellipse is similar, but it's a little bit different. So it's a collection of points in the plane such that if you measure the distance from a point on the ellipse to a point, and then another point on the ellipse to another special point, it always adds up to a constant. The constant is constant for a given ellipse, but you can have different constants in different ellipses. I'm going to show you what I mean. So let me get a picture of an ellipse. Okay, so there's an ellipse. Point E is going to be a point that always travels around the edge of the ellipse. Points B and C are fixed, and they are inside the ellipse. I'm going to drag point E, and as I drag it, this distance and that distance will change. Okay, so it's actually going to be measuring those 2 line segments, EB and EC. But if you add together those 2 numbers, the length of each line segment, in this particular ellipse, it will always add to 17.3. That's what this one always adds up to. Okay, so I'm going to drag it and show you. So you can see I just changed it a little bit. The line segment EB got a little bit longer. EC got a little shorter, but if you add them together, they still add up to 17.3. And that'll be true no matter where I put this one. Okay, that's about as short as I can make line segment EC, 1.73. Now it's going to start growing again, and line segment EB is going to decrease. add those two numbers together, they always add up to 17.3. Now, it doesn't have to be 17.3 in every ellipse. That's just this one. If I change the size of the ellipse, it would be a different number. And that's how you'd actually draw an ellipse. Like if you wanted to make a real ellipse, you could take, like if you had a piece of wood and you put a nail at one point and then put a nail in at another point and take a loop of string, put it around the two nails, pull it tight, and stay tight the whole time and go right around, and you'll make an ellipse. So it's kind of like a circle. With a circle, you just put in like a single nail, attach a string to it, and then go around. This is two fixed points, and that's how you make an ellipse. The further apart these 2 points get, the more elongated the ellipse becomes. As B and C get closer together, the more circular it becomes. And if B and C become the exact same point, then you have a circle. That's why we're going to look at circles and ellipses today, because they're both kind of the same thing. Okay, those two special points inside the ellipse, those are called the foci, plural of focus. Okay, so an ellipse has two foci, and they are always inside the ellipse. The ellipse wraps around them. Okay, so here's a diagram. We're going to go through some of these terms as we keep going. But this part is describing the definition of an ellipse. If you measure the distance from point to the first focus and from the point to the second focus and add those two distances together, you always get a constant. F1 and F2 stand for the two foci. Focus 1, focus 2. P just stands for a point anywhere you want along the ellipse. Anyone ever guess what the V1 and V2 stand for? They're the edges of the ellipse, the long way. And in this particular problem, the long way is horizontal. You have a guess? Yeah? Yeah, they are vertices. So when you draw a line through the foci, that line is called the major axis. There's two axes in an ellipse. There's a major and a minor. So the major axis goes horizontal in this case. The minor axis is going to go vertical. The major axis always runs the long way. The minor axis goes the short way. Now, if you find the midpoint of the segment that connects the two foci, that is the center. So if you drew in this line segment in purple, and you knew the coordinates of F1 and F2, and you find the midpoint, that is your center. Now, if you draw a line through the center perpendicular to your major axis, you get the minor axis. So these are at 90-degree angles. So one thing with conics is there's a lot of vocabulary. And for each conic that you study, the vocabulary changes a little bit. If we did parabolas, there's no such thing as a major, a minor axis, a center. There is a focus and there is a vertex in a parabola, but it's singular. In an ellipse, it's plural because there's two. Okay, so each conic has its own vocabulary that goes with it. With ellipses and hyperbolas, a lot of the vocabulary is almost identical. Parabolas are a little different. So if you look at where the major axis crosses the ellipse, that is where the vertices are. So the vertices are shown as the red dot way on the left and on the right. And that's where the major axis crosses the ellipse. Now, one thing that's nice about an ellipse is there's only two categories of ellipses. You either draw an ellipse that's more horizontal, or you can draw one that's vertical. So either like this or like this. When you study parabolas, there's 4 types of parabolas. You can have a parabola that opens up, down, left, or right. So there's a little bit more going on with parabolas because you have to be careful of which way it's opening, and that's going to control your equation. Well, they have 2 choices with ellipse. It's either a horizontal or a vertical. Any question why there's only going to be 2 different cases? We don't draw ellipses on like a 45-degree angle. You can, but we don't. So some of the things that we're going to do might be graphical, where I ask you to take a picture and give me information, like here's a picture of an ellipse. Tell me everything you can about it. Tell me where the major axis is, the minor axis. Tell me the vertices, the foci, the center. Or I might reverse that, and I'll tell you that information. I'll say, here's an ellipse, has a center here, vertices here. Make a picture of that. But no matter which way we're doing it, whether I give you a sketch and you tell me about it, or I tell you about it and you create the sketch, you have to know the equation. So every conic section that we study, we're going to start with it at the origin. That's the simplest way to start. So center is going to be at the origin. And the foci are going to be left and right. Okay, we're going to do the case where the ellipse is more horizontal. The foci will be symmetrically placed around the center, but we're going to have to figure out what the C value is. C is always going to be the distance between the center and the focus. So that's something we want to remember. C is the distance from the center to the focus. And I'll keep that off to the side so we remember that. In this problem, the major axis is going to be horizontal, and all the important points are along the major axis. The center, the vertices, and the foci. Everything is along the major axis. The vertices are going to be symmetrically placed around the center. And when your ellipse is horizontal, you're going to have a vertex A units to the right and to the left of the center. So A is always the distance from the center to the vertex. Center to vertex. Now, I kind of skipped over a letter, B. There is a B in the formula. I'm going to show you what B is, but they're generally not going to give you all 3 letters. They'll give you 2, and you have to figure out the 3rd one. And there's an equation that lets us do that. So that is the equation of our ellipse. X squared over A plus y squared, x squared over A squared plus y squared over B squared equals 1. A is always bigger than B. So if you have 2 numbers and you don't know which one is A and which one is B, A is the bigger one. That's how it always has to be. And that's the formula that connects A, B, and C. C squared equals A squared minus B squared. So as long as you know 2 out of the 3 letters, you can figure out the third one. So notice C isn't in the formula anywhere. It has an X, a Y, an A, and a B. Well, a lot of times they're going to give you C. Even though you don't need it for the equation, you're going to need it to figure out something that goes in the equation. You're going to need C to figure out A or B. So let me explain what B is. Actually, I'm going to write them down right here. So A is the distance from the center to the vertex. C is center to focus. And B is the distance from the center to where the minor axis hits the ellipse. So if you know A and B, you basically know the points of the 4 edges. I call them like the edges of your ellipse. So if that's your ellipse, that's a vertex. That's a vertex. Right? Those are going to be A units away from the center. B would give you those 2 dots in green. Okay, so this distance right here, that's B. This distance over here, that's A. A is center to vertex, B is center to where the minor axis crosses the ellipse. So what would be the distance between the 2 vertices? Yep, 2A. So if they give you a problem and they say the distance between the 2 vertices is 10 units, well, they didn't give you A directly, but if you know the distance between the 2 vertices is 2A, then A must be 5. Okay, so there's facts like that we have to put together to figure out the A, the B, and the C. Does everybody have those 3 things on the board? Okay, so let's try an example. Every equation we do right now is always going to be center at the origin. At the end, we'll look at somewhere we should. Okay, I'm giving you the center, the focus, and the vertex. First thing you generally want to do is graph those points and see what kind of ellipse you have. Is it an ellipse that's going to be horizontal, or an ellipse that's going to be vertical? What kind of ellipse do you think this one's going to be? If we graph all those points, how do they line up? Yeah?
Horizontal.
They line up horizontal. The y values are the same for all of them. If you have points where the y value is the same, they are in a horizontal line. So your center is 0, 0. You have a vertex at -4, 0. Now, they didn't tell us this, but where else do you have a vertex? Yep.
At 4, 0.
You also have one at 4, 0. And they also tell us that the focus is at 3, 0. 1, 2. So focus over here. And where else do we have a focus? Yep.
-3, 0.
-3, 0. Now, the foci are not important points on the sketch of the parabola. The foci are inside the parabola. So they would be important if you actually wanted to make this parabola you'd put in like a pin here, and then you'd put your piece of string over the two red dots, and it would make the ellipse. Okay, but the foci are not points on the ellipse. If I say parabola, I mean ellipse. I'm teaching parabolas period 1, so it's in my mind. Okay, so the first thing we need is to identify A, B, and C. Okay, we have to figure out those 3 letters. A, B, and C. Now, what I want to do is look at the difference between this equation. Okay, this is for a horizontal ellipse. And I want you to just quickly look at the vertical ellipse and see if you can tell me the difference from this equation. How does this equation look different? Yeah?
A squared and B squared are swapped.
The A and the B squared are swapped. And what do we know about the relationship between A and B? That's the connection, yeah?
B is the smaller one.
B is the smaller one, so A is the bigger one. Whatever letter that A is under, that is going to be the direction that your ellipse goes. If the bigger number is under Y, that's going to give you a vertical ellipse. If you put the bigger number under X, the ellipse is going to go in the X direction. So A is always the bigger number, and wherever you put A, look at what's above it, and that letter will tell you the direction of your ellipse. Everything else is the same. It's still x squared in the upper left, y squared in the upper right, and it always has to equal 1. If it's not equal to 1, you need to fix it so it is. So when you're writing your equation, you could always start with this. X squared there, plus sign, then a y squared, and then an equals 1. Both equations always look like that. We just have to figure out where the A and the B go. Since our ellipse is horizontal, it's going to look something maybe like that. I want the bigger number under X to make the ellipse go in the X direction. So A squared here, then B squared. Now we got to just fill all that in. Okay. With the information they gave me, what do I directly know? A, B, or C? Something there that I know, maybe a couple things I know. Yeah?
A and C?
Yeah, what's A going to be?
A is going to be 4.
A is the distance from the vertex to center. Vertex to center. What's the difference between those 2 points? They are 4 units apart. Okay, so vertex to center. Got it. And you said we know C. What's C?
The distance from the origin to the focus. So it's 3.
And what is it in general?
From the center.
Center. This time the center is the origin, but we're going to shift it in a little bit. Okay, but C is the distance from the center, which is the origin this time, to the focus. Origin to 3, 0, that's 3. So we got 2 out of 3 things we need. But B, that's the letter we're missing. And what's the formula that connects A, B, and C? Yep.
C squared equals A squared minus B squared.
C squared equals A squared minus B squared. What can get a little tricky is when we do hyperbolas tomorrow, almost everything is identical except the signs switch. We'll end up with a minus in here, and you're going to end up with a plus there. So it's very easy to mix up ellipses and hyperbolas. Even though they look totally different, the equations are almost identical. Okay, so let's fill in what we know. So C squared, A squared, so bring the 16 over, and 9 minus 16 is going to give me how much? How much?
7.
-7. Then you can cancel the negative from each side. So b is the square root of 7. Now, visually, that number tells us the distance from here to here. So I don't know if I drew that to scale, but I should be square root 7 units up and down to get to the top and the bottom of the ellipse. But we're not sketching it. The important thing we need that for is the formula. So b is the square root of 7. So what's going to be the equation for my ellipse when I fill in the a and the b? Yeah.
X squared over 16 plus y squared over 7 equals 1.
7 equals 1. And that's how you leave your equation. Now, if I wanted to draw that, just to see if the sketch looks like the one that I did, when we put this in on the calculator, what would we have to do to it? You can't put it in like this. Yep.
You have to isolate y.
We have to isolate y. So let's isolate y. It's only probably 3 steps, and then we'll type it in. So the first thing I would do is subtract the, I'm going to think of this as 1, well, I'll do it as x squared over 16. I was going to think of it as 1/16 x squared. I'm not sure that's going to really save me work. Okay, so subtract the x squared over 16. Multiply the entire thing by 7, and then take the square root. So here's times 7. That clears my denominator. And now take the square root. And remember, when we draw an ellipse, it's not a function. For every input, there's 2 outputs. So that's where the positive and negative square root are going to come from. Because it's not a function, I can't even really draw it. All I can do is the top half, and then the bottom half separate. All right, let's draw it. And let's see if we get an ellipse that looks kind of like that. Okay, so I need square root of, I'm going to be careful with parentheses, 7 times 1 minus x squared over 16. I think that looks right. And I could type the same thing in with a negative, or I can just do negative and do the negative of y1, and it saves me a little time. Okay, let's do zoom 6 and see what we've got. Here's your ellipse. Vertices are at 4, 0, negative 4, 0. And if I calculate this maximum for that part in blue, what should be the y value of the maximum? Yep.
Root 7.
Should be root 7. Let's check it. Second calc maximum. Let's go left. Let's go right, do a guess. We get 2.64575. And if I take the square root of 7, 2.64575. Exactly the same. Okay, most of the time you don't need to rearrange it to sketch it, but it did give me a way to check and make sure my b value was correct. Any questions on that? That's an ellipse. Let's try this one. So this time I'm going to give you the equation, and I want you to tell me all about it. Okay. When you're describing an ellipse, the things that I will always want to know are the center, vertices, foci, and the direction of the major axis. I don't really need to know the minor axis, because if you tell me the major axis, I know the minor goes the other way. First thing you always want to do is identify the A, the B, and the C. Okay, what is A in this case? Yep.
5.
It's always the bigger number, so look at the 25 and then take the square root. Okay, what's B? Yep. 3. Now, we can describe some things with A and B. Like I can do the vertices, but I can't do the foci unless I solve for C. What's the formula that we use to solve for C? Yes.
A squared minus B squared equals C squared.
A squared minus B squared equals C squared. So 25 minus 9 equals C squared. So we know C is 4. So let's write down some of the things we want to know. First thing I want to know is the center. Then the direction of the major axis. Then the vertices and the foci. Okay. Where's the center going to be for this ellipse? Yep.
0, 0.
Yeah, it's going to be 0, 0. How will you know when it's not 0, 0? These are going to look a little more complicated. You're going to have x plus or minus a number, and y plus or minus a number. Something like, if you had something like that in the numerator, that's going to be a shift 2 units horizontally. And that would be to the right 2 units. Okay, so you'll know when it's not at the center. It's going to look more complex. What is the direction of the major axis? If we get this wrong, then we're going to get all the spacing wrong on everything else. So we've got to get the direction correct. Yeah.
Horizontal?
This is horizontal. Look at the bigger number. Look at which letter it's under. Bigger number under x means the ellipse goes in the x direction. Okay. Vertices. What letter has something to do with the vertices? A, B, or C? Yeah. A. How far away are my vertices from the center? Yeah. 5 units. And are they 5 units left and right of the center, or 5 units above and below?
Left and right.
Left and right. We know it's left and right because we've already figured out the direction of the axis. So we need to go 5 left, 5 right. Okay. What's the coordinate that's 5 left of the origin? About 8.
5, 0.
Perfect. And Lucas, what's the coordinate that is 5 units to the right of the origin?
5, 0.
Yeah, 5, 0. Okay, so we got our vertices. Last thing they want us to give is the foci. What letter there helps you to find the foci? Yep.
C.
C. And how far are the foci in this problem from the center?
4 from each side, so -4, 0, and 4, 0.
Right. Foci are 4 units from the center, and they're 4 units left and right. Okay, so it's a lot of things to keep track of, but if you know what the A, the B, and the C do, that's the most helpful thing. Okay. Any questions on that one? All right. So So let's look at the equation of an ellipse that now is vertical. So A and C are still going to mean the same thing. A is how many units the vertex is from the center. C is how many units the foci are from the center. But instead of being left and right, everything now is above and below. So the major axis is the y-axis. And we already talked about what makes this equation a little bit different. The bigger number now is under the y. Bigger number under y means the ellipse is going to go in the y direction. Yeah, everything else is the same. A is always bigger than B, and B is bigger than 0. So no negative values for A and B. And that kind of makes sense because when I described A and B to you, I described them as distances. Well, distance can't be negative. And the connection between A, B, and C, C squared equals A squared minus B squared. Okay, make sure you get that idea in your head. C squared equals A squared minus B squared. That is only for an ellipse. Tomorrow, it's going to be C squared equals A squared plus B squared. That's a hyperbola. So you just have to keep them straight. Okay. So they want us to discuss that equation. Now, one way that you know this is an ellipse, because on the test, you're going to have to decide whether the conic section is an ellipse, a circle, or a hyperbola. Well, first of all three of those conic sections I just said, the x variable is always squared, and the y variable is always squared. In a parabola, that's not true. One is squared, one is not. Okay? But we're not looking at parabolas. If this was a hyperbola, you need a minus in there. In a hyperbola, one of the squared terms has to be negative and one has to be positive. When they are both positive, you're automatically dealing with either an ellipse or a circle. And then how you differentiate between which one, you'll see. All right, so they want us to discuss this, but there's a problem with that equation. What's the problem with that? Yeah?
Did I say why?
No, we want to keep it in a form like this. We would have to isolate y if we wanted to drop it on the calculator. But we don't necessarily have to isolate y if we're just going to discuss it. But there's definitely a problem with that equation. Yeah?
Does the 9 need to be a 1?
Needs to be a 1. Okay? To identify the a and the b, you can't have it equal 9. You need to have it equal 1. How are we going to make that equation equal 1? Imagine.
Divide by 9 on both sides.
Yep, I'm going to divide everything by 9. So that's going to give us, and I do want to leave a denominator, even if it's a 1, just to mentally help us remember there is a denominator. So it's now going to be x squared over 1 plus, you're just going to leave the 9 in the bottom for the y, and now it's equal to 1. Okay, so we're going to discuss it. But before we get to that point, what are the first 3 things we want to identify? Yeah.
A, B, and C.
A, B, and C. Okay. What is A in this case? A is 3. It's the square root of the bigger number. And what about B? 1. Square root of the smaller number. And what about C?
Root 8.
Yep, root 8. want to reduce it, you could say 2 root 2. Okay, so we got A, we got B, we got C. 4 things we have to describe. What's the first thing that you generally want to describe about an ellipse? Yep.
The center.
You want to know the center. That's the first thing. If you get the wrong center, then everything you measure from the center is wrong. So you've got to get the center right. Okay. What's the center of this ellipse? Yep.
0, 0.
Yep. 0, 0. Again, you'll know when it's not 0, 0. That numerator is going to look more complicated. After you describe the center, what's the next most important thing? Yep.
The direction of the major axis?
Right, you've got to get the direction of the major axis. If we get that wrong, then everything is going to be spaced the wrong way. Okay. Which way does our major axis go? Yep. Vertical. Bigger numbers under y, major axis goes in the y direction. So now we want to be thinking in our head, everything is above and below center, which means the x value of our vertices and foci is going to be the same as the x value of the center. Which one you do next now, vertice or foci, doesn't matter. Let's do the vertices. Make sure when they ask you for vertices that you do both. What are going to be my 2 vertices for this ellipse? Yep.
0, negative 3, and 0, 3.
Yeah, so we technically, when it's at the center, you can use a notation like that and it'll work. When when your center's at the origin. When your center's not at the origin, that doesn't always work. Your vertices are 0, 3, 0, negative 3. And how about my foci? Where are those going to be? How about Elise? Where are my foci going to be?
0, 2, 2, and 0, 2, 2.
Yeah, and again, so because the center is at the origin, the numbers are going to be symmetrical. So I'm going to use that plus or minus notation. And that is everything that important I would ask you for. Any question on that one? All right. Let's try this one. Now I want you to find the equation. And foci are, well, there it says a focus is at 0, 2, and the vertices are 0 plus or minus 3. This piece of information tells you something. If you know the vertices are at 0, 3, and 0, negative 3, what else does that indirectly tell you? Yes? Yes, it tells, so it does tell us it's vertical. So bigger number under y. Something else I was thinking of too, but that's correct. What else does this tell us? It tells us the location of something else. Yeah. It tells you the center, because the center is always halfway between the 2 vertices. Well, if you've got one at 3, 0 and negative 3, 0, what's right in the middle? The origin. Okay, so we know the center is 0, 0. So I can write that down, even though it wasn't given. Okay. What's, well, actually you tell me, what's one of the letters that you know here? Yep.
A.
Yep, what's A?
3.
A is 3. Distance from center to vertex. That's important. Something else we know?
C is 2.
C is 2, center to focus. Unfortunately, that's not a letter we need in the equation, but you're not going to get the letter we need without that. So C is 2. And what's the formula that connects A, B, and C? Yep.
C squared equals A squared minus B squared.
C squared equals A squared minus B squared. So 4 equals 9 minus B squared. So what does B come out to? And technically, we don't need B. We need B squared for the formula, but we can write B. Root 5. Yep. Okay, so we got everything we need. Now we have to decide on the type of equation. We have 2 to pick from, the vertical and the horizontal. And someone already said that it's going to be the vertical one. X squared plus y squared, 1, fraction, fraction. A is the bigger number, and that's going to go under what letter in this problem? Yep. We want the A squared under the y. So you want a 9 here, and you want a 5 there. And there's your equation. Okay. Any questions on that one? Okay, let's do one where I give you a picture, and you do the same thing. You tell me the equation. Let's do... I'll zoom in a little so you can see it better. Let's make an ellipse. And if you have one that is a graph, they're going to give it to you as a nice numbers. They're not going to give you one where you're going to estimate decimals. That would be too hard. Let's just see how this looks. It's pretty good left to right. Just see if I can. Just trying to make it land nicely. Let's see if I did it. It's really hard to do. Let's go with, I think that'll be close enough. Just pretend they land at nice spots. That's as close as I can get it. Here, 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 and there. Oh, but that's not centered at the origin. All right. All right, let's try this one. And again, let's assume these points are all right there. At least it's centered. All right. Let's try to figure out A and B. What's A in this case? Yeah. A is 4. What's B? Again, pretend like my points are where I showed them. Yeah.
2.
B is 2. So I want to find the equation. Do we want the bigger number under X or under Y when we write the equation? Yeah, I want the bigger number under X. So what number would go under X? Yep. No, we don't want a 4 under X. Yep.
16.
16. Yeah. So 4 is the number that's going to help you figure out what goes under X, but we got to square it. What goes under Y? Yep. 4. That's a 4. And there is your equation. Didn't have to deal with C at all. Okay. So any question on writing an equation from a graph? Yes?
So, they'll accept it in that form, or do you want to isolate the line?
No, they're usually going to put it in that form for an ellipse. Yeah. When we isolate Y if you have to graph it, but we're not going to graph it. So that's fine. So a circle is really just a special case of an ellipse. How would you describe a circle using terminology from ellipses? Yeah?
An ellipse with one focus point.
Okay, so there's just a single focus. Anything else you could say? Yeah?
The A and the B are the same.
Yeah, the A and the B are the same. These two numbers are the same. So what are the A and the B? The distance from the center to the vertex and center to minor axis. So that's where if this is your center, and let's say you had a vertex 2 units right and 2 units left, then you'd have another point 2 units up, 2 units down. And that would create your circle. Okay, so the A and the B are going to be the same. So if they're the same, then we really don't need to use a different letter to describe each one of them. We can use the same letter twice. And a lot of times what they do with a circle is they don't leave it as a fraction anymore because you can easily move everything to one side. How could we get rid of our fractions here so we don't have denominators? Yep.
Multiply everything by a squared.
Right, you can multiply everything by a squared, and then you would have that. That is how they write the equation of a circle. And a lot of times they don't use the letter A. They use a different letter. Because what is that A? I mean, it was the distance from the center to the vertex. I don't really think of a circle as having a vertex. So we describe A a little differently on a circle. Yep.
Radius?
It's the radius. Yep. So it's the distance from the center to the edge of the circle. Okay, so that's all that a circle is. It's just a special case of an ellipse where the A and the B are the same. So now you know how to tell if it's an ellipse or a circle. If your denominators are the same, you have a circle. If they're not the same, you have an ellipse. And it has to be an addition side, not subtraction. Subtraction would make it a hyperbola. Small change, totally different picture. All right, so now the last thing we're going to look at is shifting the ellipse. So what a shift does is now it adds 2 more letters we have to find. We still got to find A, B, and C, but now we have to find H and K. So the first thing to understand is HK is going to be the coordinate of the center. Every problem we've done up until now, H has been 0, K has been 0. So we basically could just cross them out. And that's the formula that I gave you at the beginning of class. Now, the H and the K are not 0. When you write them, it does matter which letter goes with X and which one goes with Y. H is the horizontal position of the center. Because it's horizontal, H goes with X. K is the vertical position of the center. Because it's vertical, K goes with Y. So H always goes with X, K always goes with Y, and they are subtracted, just like that. Everything else is the same. A is still bigger than B. C squared equals A squared minus B squared. It's got to have a plus sign here. It's got to have a 1 over there. What's going to change when the major axis is vertical from this formula? Yeah.
You subtract K from X and H from Y.
No, H always has to go with X and K always has to go with Y because the coordinate H is always a horizontal, K is always vertical movement. So those have to always stay paired up where they are. Yep.
The denominators.
Denominator switch. Wherever you put the bigger number, that's the direction of the major axis. So there's your equation where the major axis is vertical. And if you look at the section from the book, this is a different book. This is the other book that I've used before when we did vectors. It's on page 394. Okay, so let's try it. Okay, center, focus, and vertex. So 5 letters we need to find. A, B, C, H, K. And find them in any order you want. What's one letter up there that we know? Yeah. Yeah, what's H? 2. Good. H is 2. What's another letter that we know? Yeah.
K.
K, what's that?
-3.
K is -3. That comes from the center. H, K. How about the, we're going to look at the focus, directrix, and center now and start thinking about distances. What's another letter that we would know? Yep. C, that's the distance between the center and the focus. How far apart are the center and the focus? 1. C is 1. And one more letter that we can figure out with really no calculation. Yep.
D? I mean,
A. Yeah, B we need to calculate. But what's A going to be? 3. A is the distance from the center to the vertex. Those 2 points are 3 units apart. Okay, so the only letter we don't know is B, and we're going to find that using our formula. Okay, so C squared, A squared we know is 9. I think we had one similar to this earlier. What does B come out to here? Yep.
2 root 2.
2 root 2, right? If you bring that to the other side, you get -8. And then, yeah, I know we solved this one earlier. So 2 root 2. Or you could think of it as square root of 8. You're going to end up squaring in the formula. So if it's easier for you to think of it this way, because when you square that, you get 8, then think of it that way. But that's the reduced version, 2 root 2. Okay, let's figure out our formula. Don't even have to think about the direction yet. What goes in the first numerator, whether it's horizontal or vertical? Just looking for just letters. Yeah.
Parentheses
X minus H. This is always a plus. What goes in your second parenthesis? Our second numerator. Yep.
Y minus K squared.
Always going to be y minus k. It's always going to be equal to what value? Yep, 1. Now we got to think about the denominator. We know it's an a squared and a b squared, but we got to put them in the right spot. How do these points line up if you draw them? 2, -3, 3, -3, 5, -3. They all have the same y value. So how do points with the same y values line up? Yep. Horizontal. That means all those points have to be along the major axis. So you want the bigger number under x. What's going to go under x in this case? Yeah, 9. A squared. And what's going to go under y minus k? Yep, 8. Almost a circle. Close. Just a little bit wider than it is tall. But that, oh yeah, we actually have to fill in one more thing. Fill in for h. What do we get? 2. And fill in for k, we get -3. So what happens when I fill in -3 in the numerator? Gonna become addition, yep. So y minus -3. And that's what you want to write. Don't forget to fill in for h and k. Any questions on that?
That's it.
Okay, so put up the homework. So you have to change question. Okay, so homework 13 to 17, that's all. And then everything else is off.